Hi, my name is Tomas Guevara, and this is the channel Rewriting the Reality. One of the purposes of this channel is to debunk all the information that sciences are given to us and that is inaccurate. To be well informed, please subscribe to this channel now. Did you know what a black hole is? I asked ChatGPT about the discovery of black holes and here is the answer. The discovery of black holes is a fascinating story that involves a combination of theoretical predictions and observational evidence. Here's a brief overview of how scientists were able to discover black holes. First, theoretical predictions. The concept of a dark star was first proposed by the British natural philosopher John Michell in a letter to the Royal Society in 1783. He suggested that there could be stars so massive and dense that their gravity would be strong enough to prevent light from escaping, making them invisible or dark. However, the term black hole was coined later by physicist John Archibald Wheeler in 1967. Second, general theory of relativity. Albert Einstein's theory of general relativity, published in 1915, provided a new understanding of gravity as the curvature of spacetime. Einstein's equations predicted the possibility of objects with extremely high mass and density that could create such intense gravitational forces that even light would be trapped by their gravitational pull. Third, stellar evolution. Astronomers also developed a deeper understanding of stellar evolution, which led them to predict that massive stars, much larger than our Sun, would eventually exhaust their nuclear fuel and undergo catastrophic collapses at the end of their life cycles. Fourth, X-ray observations. One of the significant breakthroughs in the discovery of black holes came from observations of X-ray emissions in binary star systems. In the 1960s and 1970s, astronomers detected powerful X-ray sources that didn't have a visible star companion. These X-ray binaries exhibited characteristics suggesting the presence of a compact, massive object, likely a black hole, accreting matter from a nearby companion star. Fifth, event horizon telescopes. In recent years, scientists have developed a technique known as very long baseline interferometry, VLBI, to observe black holes directly. The Event Horizon Telescope, EHT, is a prime example of this technology, involving a network of radio telescopes located around the world that work together to create a virtual Earth-sized telescope. The EHT captured the first image of a black hole's shadow in 2019, specifically the supermassive black hole at the center of the galaxy M87. Sixth, gravitational waves. In 2015, the Laser Interferometer Gravitational Wave Observatory, LIGO, detected gravitational waves for the first time, resulting from the merger of two stellar mass black holes. This groundbreaking observation provided direct evidence of black holes' existence and further confirmed Einstein's theory of general relativity. Overall, the discovery of black holes is the result of decades of theoretical insights, astrophysical observations, and technological advancements. While black holes themselves are invisible due to their strong gravitational pull, scientists have been able to infer their presence and characteristics through various indirect methods and sophisticated instruments. I decided to ask the next question: how can we take a picture of a black hole in color if light can't escape from a black hole? The answer is, taking a color picture of a black hole might sound contradictory since black holes, by definition, are objects that prevent any light from escaping their event horizon. However, what we can do is take an image of the surroundings of the black hole, known as the accretion disk, and the effects of the black hole's gravity on light and matter in its vicinity. This image may display colors, which are not emitted by the black hole itself but instead arise from the surrounding materials. The first ever image of a black hole, captured by the Event Horizon Telescope, EHT, in 2019, was not a traditional color photograph but instead a composite image generated using a technique called radio interferometry. The EHT is designed to capture radio waves emitted by the superheated gas and dust swirling around the black hole. Here's how the process works. First, radio observations. The EHT is a network of radio telescopes located around the world. These telescopes work together to create a virtual telescope with an Earth-sized aperture. They observe the radio waves emitted by the hot gas and dust in the accretion disk surrounding the black hole. Second, data collection. The telescopes record the radio signals received from the black hole over a certain period, creating vast amounts of data. Third, data analysis. The data collected from different telescopes are combined and analyzed using a technique called interferometry. By combining the signals from multiple telescopes, astronomers can achieve a much higher resolution than is possible with a single telescope. This process effectively simulates a telescope with an aperture as large as the Earth. Fourth, image reconstruction. The interferometry data is then processed and reconstructed to create an image of the black hole's surroundings. This image is not in the traditional visible light spectrum that we see with our eyes, but instead represents the radio emissions from the accretion disk. Fifth, representation is color. After the image is constructed, it can be colorized for visualization purposes. The colorization is not meant to represent the actual colors of the black hole, but is rather used to highlight specific features, or differences in intensity. So, while we can't directly take a color picture of a black hole itself, we can capture images of the surrounding materials, and represent them in false colors or as a grayscale image, giving us an impressive glimpse into the fascinating phenomena occurring near black holes. In other words, these are theories or speculations done by the scientific community. On August 1, 2019, the Indian Express published a report titled, "Scientists have found the only star that escaped a supermassive black hole." Scientists have discovered the only space object, a lone star, that has managed to escape the force of a supermassive black hole. This is unique because the gravitational pull in a black hole is supposed to be so strong that nothing can escape from it, not even light. The news about the star which escaped the force of the black hole comes a few months after astronomers across the world showed the first ever image of a black hole. A man-made picture, I would say. The report continues, scientists have successfully tracked down the star, named S5HVS1, which was kicked out of Sagittarius A*, which is a supermassive black hole lurking at the heart of the Milky Way. Here is probable a mistake. The star was kicked out of the Milky Way, not from the black hole. The report continues, the supermassive black hole is claimed to be moving at a speed of 1,700 kilometers per second. According to research by a team of space researchers. According to a research paper titled The Great Escape, Discovery of a nearby 1,700 km per second star ejected from the Milky Way by SGR A*, the star has already spent around 4.8 million years on a lonely journey in the space after it was kicked away from the Sagittarius A** black hole. When integrated backwards in time, the orbit of the star points unambiguously to the galactic center, implying that S5HVS1 was kicked away from SGR A* with a velocity of ~1800 km per second, the researchers wrote in the paper. The discovery was made during a project called the Southern Stellar Stream Spectroscopic Survey. The scientists said their data proved the runaway star can be unambiguously traced back to the galactic center. In a previous report, NASA says that the Sagittarius A* black hole is just 26,000 light-years away from Earth, and it is one of the very few black holes in the universe where we can witness the flow of matter nearby. Therefore, the first question is, do black holes are real? My answer is, yes, they are real. They are energy deposits. Second question is, do black holes have mass? My answer is, not they don't have mass. Mass is an attribute of matter. But black holes don't have matter. They are deposit of energy so dense that nothing can penetrate a black hole. In the episode 7 and 8 I explained how our personal energy centers works. We have been calling them chakras. Black holes are the chakras of the universe. The body uses the energy of the chakras to perform some duties. The planet or stars surrounding a black hole use its energy to perform their duties, like rotation and maintaining their position with respect to other stellar bodies. We are always surprising ourselves with new creations and then discovering what we created. For almost 2 centuries, the belief was that nothing can escape the gravitational pull of a black hole. This star proved that this belief was wrong. A star created by us to prove to ourselves that we were wrong. That is the truth, a very simple answer. Don't forget to subscribe to this channel.